All right, let's look at the second law of thermodynamics to predict spontaneous change. Cool question here. We're not using numbers. We're looking at the reaction and the surroundings to see if we think it'll be spontaneous based off the words. And so what we learned in class is that if the entropy of the universe is increasing, then something will be spontaneous. And we can determine that here with two bits of information. One being, does the entropy of the reaction increase? So is that positive? Is that delta S positive? And then the second part of that is, does the entropy of the surroundings increase? Now, the easiest way to determine that we saw was through the enthalpy. If the reaction releases heat, so it's exothermic, then it's going to increase the kinetic energy or the temperature of the surroundings. It's going to transfer heat, and so those will become faster moving, which is an increase in entropy. So we're looking for a couple things. If the entropy of the reaction is positive and the enthalpy is negative, then we get a spontaneous reaction. Now there's three other options, right? If the entropy of the system is positive and the enthalpy is positive, then we have one going each way. One's increasing the entropy of the universe, one's decreasing the entropy of the universe. And so we don't know, not enough information, can't decide. It would be dependent on temperature, which we'll learn more about. Now, same thing if we go where the entropy of the reaction is negative and the enthalpy is negative, we still can't decide. Again, dependent on temperature. And then the last one is if the entropy is negative and the enthalpy is positive, then it cannot be spontaneous. There's no way it'll be spontaneous. So for each of these questions, we're going to be looking at the combination of these two things. Now, entropy, remember, we determine by what's going on in the reaction. If things become where they're moving faster or more separation, entropy increases. So that would be a solid to a liquid, or a liquid to a gas, or a liquid to a solution is an increase in entropy. So those are the type of things we're going to look at. And then we're going to look for those words exothermic, endothermic, or releasing or absorbing heat. Okay, so let's look at this. First one, we got a liquid plus a liquid. It's becoming a solution, maybe aqueous, or maybe just a solution of some sort. So that is an increase in entropy. And now it says neither absorbing nor releasing heat. So I guess that's another option, but that would be delta H being 0. So it is not part of it. And so since we have an entropy that's positive and the surroundings are not part of it, we're going to say that it would be spontaneous. Okay, so that's a good example of something that kind of fits outside of those four options. During an exothermic chemical reaction, so now we have delta H being negative, a solid is consumed and a gas is produced. So that means we're going from a solid to a gas, at least part of the reaction. Maybe there's more to it, but a solid is being consumed and a gas is being, so that is a huge increase in entropy. So delta S is positive. So again, we're going to say yes. Then now we have an endothermic chemical reaction. So we have delta H being positive between two liquids, resulting in a gaseous products. And so this is delta S being positive. And so we go to here and we see this is one of our question mark ones. So I'm going to say I can't decide with this information. So lots of different options here. And it's just reasoning through what's the entropy of the system and what is the enthalpy, and determining which one of these four does it fit. If it's the top one, it's spontaneous. If it's the bottom one, it's not. Otherwise, you can't decide. There we go.